Hi everyone, welcome to Jawaras. Let's continue our discussion of Spring IC container. In this video, we are going to talk about internationalization using message source. But before that, let's look at application context interface. Application context interface provides us a functionality which are included in Bean Factory. Apart from that, it also provides us some other great utilities. Because application context extends environment capable interface, this provides us functionalities to deal with different environments using profiles and properties. And it also extends listable bean factory and hierarchical bean factory interfaces. So it provides us a functionality to deal with multiple beans of the same type and to load multiple contexts. Application context also extends message source, which is responsible to accessing messages in internationalization style, and it extends application event publisher interface, which provides the functionality of events publication. At the end, application context interface extends resource pattern resolver interface, which provides functionality to access resources using URLs, files, and class paths, etc. So let's look at message source. So message source provides internationalization functionality. Whatever the text is visible to the user, you don't want to hard code that text because the text may change later and the same text may be visible at different places. In that case, if you need to change the text, you need to go at different places and change that text. Also, if you support multiple languages or multiple locations and you want to display different text based on the user's region or user's selected language, in that case you may end up writing many if else statement. So based on the user's local, you may display different texts, but it's more convenient if all these text files are placed somewhere else and your application logic is somewhere else. To accomplish that, we use message source. So message source provides internationalization functionality. So it has three methods. The first method takes code, which is code for the message, then arguments. So these arguments will replace placeholders in the message, and it takes default message. If that message is not present in the message files, the default message will be used. And at the end, it takes local. So what is the user's local? Similarly, there is second method, but it doesn't take any default message. And if that message is not present, it will throw an error. Then the third method takes message source resolvable. So if you look at message source resolvable interface, you will find that it has three methods which we need to implement if we want to use message source resolvable, which is get arguments, get codes, and get default message. And those are the three arguments which we used in the first get message method. So this resolvable will provide these three informations, and we need to pass local here as well. So let's see how do we do that. So first of all, we need to define these messages. So let's do that. So for that, we create files with the name dot property. So let's create a file called messages dot properties, and here the title is the message code and welcome to library is the message. So let's say title equal to welcome to library, and let's create another file which is messages underscore author dot properties. Now here code is authored dot count equal to 0 has written 1 books. So 0 has written 1 books. So here 0 and 1 are placeholder which will be replaced when we call get message. We will see that soon. So we have defined these messages. Now let's add these messages to the source. For that we need to create a bean of type message source. So let's do that. So I have a project config file here, and here let's create a bean of type message source and give it any name. So the name of the bean should be message source. But due to some reasons, if you cannot give the method name message source, let's say you give the method name ABC, in that case you need to explicitly provide the bean name message source. Now let's create a message source here. So message source is an interface, and here resource bundle message source implements message source interface. So we will use resource bundle message source here. Resource bundle message source equal to new resource bundle message source. Then we need to provide it the files where we can find the messages. So to do that, we call set base name methods, and here we can provide any number of files. So we will provide two files, messages, and keep in mind that you don't and you should not provide dot properties extension. Just provide the base name messages underscore author and return this message source. So we have created a bean of type message source. So we have added messages to the source. Now let's read the messages. So in order to read the messages, first of all we need to create an application context, and we have seen that application context has all the functionalities of message source. Since application context extends message source, so we can call the methods which are available on message source. So we can say context dot get message, and here we provide three things. One is the code of the message, which is title. The second is null, so we don't want to provide any arguments because title doesn't have any placeholders. Then we can provide default title here, and we can provide the local, so which local to use. The default is local.english. So let's do that. Go to main.java. First create an application context. Application context will be new annotation config application context, and the configuration file name is project config.class, and let's say string title will be context.get message. So first is code is title, then the arguments, let's not provide any arguments, then the default message, let's say default title, then we need to provide local, so local.english. So English is the default local, and let's print out the title. So let's run it. Now we can see we are printing welcome to library. Now let's say we need to have the code as heading, then the default message, default title. So since there is no message with the code heading, so the default title will be printed. We run it, default title. Now let's see how to read message with placeholders. So here we want to read message author.count, which has two placeholders. For the first placeholder, we want to provide the method value author1, and for the second placeholder, we want to provide the value 12. So we can create an array of objects, the first with the value author1, second with the value 12. So let's just do that. So let's create string message will be context dot get message. Now code is author dot count, and the arguments, let's not provide any arguments for now. Let's not provide default message as well. Let's say local dot english and print out message. So you can see if we don't provide any arguments, we see 0 has written 1 books, so nothing gets replaced. Now let's provide the argument. So new object And let's say we only provide one argument, say author 1. If we run it again, so now you can see the first placeholder has been replaced, but the second is as it is. And let's provide 10 here. Now both of these placeholders will be replaced. Now let's provide more than the number of placeholders, let's say 13, and it will be run. We don't see any error. So um, the place of placeholders will be replaced with the corresponding replacements or corresponding arguments which we provide. If there are more arguments, they will be ignored, and if there are more placeholders, they won't get replaced. So that's how we read the messages. Now let's see how to inject message source dependency inside any service or anywhere. So let's say you have a service and the service is responsible for printing or returning the message. So that needs to hold the reference to message source. So it's very easy to inject message source. Just do whatever we need to do to inject any bean. So here we have a author service with service annotation, and we have instance variable message source, and we are auto wiring it using setter method. We can auto wire it using uh, field annotation. Mm, that means using auto wired annotation on the field, or we can auto wire it using constructor as well. So it will work. So I already created an author service, and here I have annotated it with service, and we are using setter injection to set the value of message source. And we have already created a bean of message source in the project config, so this will be injected. Let's say how do we read the message. So it's similar because context is also a message source. So we can read the message in the same way which we have read the message from the context. Just use message source dot get message and provide the same arguments. So here we have a print authored books method inside author repository, which takes author, number of books, and local, and it passes the author's first name and number of books in the arguments parameter of get message method and local as well, and the code for the message is author dot count. So I already created this method here, print authored books. But since this author service is inside author package, and we need to tell Spring IC container to scan the author package to register all the beans inside this package. For that, let's go to project config, and here use annotation component scan, and this will be a array. So first value will be author, and it will work. Now let's go to main.java, and let's clear these. Let's get author service. So author service, get the author service from the context, author service dot class. Now let's call that print authored books method. So author service dot print authored books. So first it takes one author. So let's create author first. Author will be new author. It takes first name, let's say ABC, last name, let's say DEF. So print authored books, let's give it to author. Then we need to give how many books printed, let's say 20, and then local. So local dot English. Run it again. Now we can see ABC has written 20 books. So it's working fine. Now let's see how to support internationalization. So far we have only seen that we can extract these messages from the Java code to the properties file. So what we could have done, that we could have created a file or a file where we can put all the constants, then it would have worked the same way. But here we need to support internationalization. That means we need to support multiple locales. So here right now, let's say I want to print this information in let's say Great Britain's or England's English. So I will say local.uk, and if I run it again, I see the same string, because if it doesn't find any message for that particular local, it will default back to the default local, which is English local. So let's use anything else. So let's say local.china, and if we rerun it, we can see ABC has written 20 books. Still we are getting the same message. We won't get any error. It will be default back to the en. So now how do we create multiple files for different locales? So for that, we just create a file with the same name, but in the name we add this suffix underscore and then the local. So underscore en underscore gb means Great Britain's English. So now how do we figure out what should be the this suffix? Like here the suffix is en underscore gb. So what should be this suffix? So to do that, what you can do is, you can just print out that local. So let's say local dot English, and let's print out local dot US, and let's print out local dot UK, and print out local dot China. And if you run it again, now you can see local dot English has string value en, local dot US has en underscore US, local dot UK has en underscore gp, and local dot China has zh underscore cn. So if you want to support English of United States, you need to have this suffix. If you want to support Great Britain's English, you need to have this suffix, and so on. So let's do that. So let's create a new file. So name will be messages author and underscore and then the suffix. So let's say suffix en underscore gb dot properties, and let's copy this one, and let's after this message, let's print mm, the local. So I will say en underscore gb. So we know that this local is working or not. And go to main.java, and let's run it again. Okay, now we can see this is being printed. But if we print for something else, let's say China something, then it will be the default one. And and the en is by default, so you don't need to use underscore en dot properties, because that is the default local. And let's say you want to support some local which is not provided out of the box, so you can create that as well. So what you can do is, let's say local, let's say you want to create a local for English of India. So you can say en in is new local. First you need to specify the language, let's say English, or let's say you want to support Hindi language of India. So HIIN English, and then you need to provide the name of the country. So let's say IN here, and we can pass this local here. Let's print out. Now you can see we are default back to the default local, and this is the local or this is the suffix which we need to use, English underscore in. But okay, it was Hindi, so let's say hi only. So if we refresh it, so this is the suffix hi underscore in which we need to use. So let's do that. So let's create a new file here with the name messages author underscore hi underscore in dot properties, and let's create this here, copy it, paste it here, and let's say Indian Hindi language. And if we run it again, now you can see we are getting the text related to that specific local. So that's how we support internationalization. That's it for this video. Thank you everyone for watching it. We will meet in the next video. Until then, keep learning. Bye.